What is an Ozark shut-in? Oh, you mean other than an introverted geologist with a YouTube channel? Today we're launching a new series of short FAQ-style videos giving brief answers to interesting questions about Ozark geology and more. In certain parts of the eastern Missouri Ozarks, rivers behave strangely. At places like Casta River shut-ins, Johnson's shut-ins, Pickle Creek, and Rocky Falls, a river flowing normally through an unremarkable valley suddenly develops claustrophobia. The valley narrows, the walls close in, and the water plunges into a tight gorge. But the constraint doesn't last long, and within a short distance the river is back out into a broader, more normal valley again. These short scenic constrictions were named shut-ins by early European American settlers, following a traditional Appalachian term for a gorge. In the Ozarks, where the term takes on an even more specific meaning, these areas have long been popular as scenic recreational spots for locals and tourists alike. But where do they occur? The kind of shut-ins we're discussing here only occur in a small part of southeast Missouri. If you've been following along in our Geology of the Ozarks series, you know that this is also the only part of the Ozarks where Precambrian igneous rocks are exposed. And indeed, the story of shut-ins relates to the presence of erosion-resistant igneous rocks. So how did these shut-ins form? The shortest answer, and the one you'll generally find in interpretive materials, is that Ozark shut-ins form when a river eroding down through relatively soft sedimentary rock hits a patch of much more resistant igneous rock. For example, here at Johnson's shut-ins, the East Fork of the Black River initially flows south through a wide valley based in sedimentary bedrock. Where the river hits a patch of igneous bedrock, it gets trapped in that more erosion-resistant material and forms a narrow shut-in. But further downstream, the bedrock goes back to sedimentary, and sure enough, the valley widens out again. Well, okay, that's fine as far as it goes. But if you stop and think it through, that's only one part of the answer. Why are these pockets of shut-in forming igneous rock so isolated and irregular? Let's do a quick thought experiment with a simplified review of the region's geology. The Ozarks have really old Precambrian igneous rocks underlying relatively younger Paleozoic sedimentary rocks. Let's assume for a moment that the contact between these is like a flat layer cake. Then consider what would happen if a river eroded a valley into it. Once the river reaches the igneous rock, it should stay within it as it continues to erode downstream. In this assumption, you think of the contact like the shoreline of a lake, following the same elevation across the landscape. Let's look at a real-world example. In this overhead view of the Johnson shut-ins area, if there was a flat contact between the older igneous rocks and the younger sedimentary rocks, it would follow a consistent line through the valleys, maybe something like this. But in reality, the igneous rock doesn't follow any consistent topographic pattern, and even tends to form the high ground, with the younger sedimentary rock down in the valleys, except in isolated cases where a river crosses igneous rock and forms a temporary shut-in. Huh? How do we explain that? Well, that flat layer cake assumption in our thought experiment was wrong. The surface separating the igneous rock from the sedimentary rock is actually far from flat. Let's step back. The igneous rocks themselves were originally formed during the Precambrian era over 1 billion years ago, through a complex history of caldera eruptions and subsurface intrusions that we covered at length in a video for our Geology of the Ozarks series. A subsequent and very long period of erosion carved out a range of large hills or modest mountains depending on your frame of reference. These had at least as much topography as the modern Ozarks, but were completely buried by a thick sequence of sedimentary rock during the subsequent Paleozoic era. Over time, uplift of the Ozark Dome elevated the region, and rivers have been carving down into it for a long time, finally reaching and exposing the ancient landscape in certain parts of southeast Missouri. Imagine being a stream or river flowing across easily erodible sedimentary rock, unaware of the ancient topography lurking below. As your channel cuts deeper, eventually, somewhere along your course, you hit some tough igneous rock. Around here, it might even be the volcanic rock called tuff.
There's some tough rock in this landscape.
Now what? Do you change course to go around it? Or cut down into it, resulting in a shut-in? There are certainly some bizarre and curious topographic patterns to be found. To quote an excellent source on this, "Why this perversity? The answer is a geologic enigma and always good for a debate." And here's an additional factor to consider. These igneous rocks commonly contain joints, or small fractures, that tend to occur in parallel vertical sets. These are weak zones that rivers can exploit as they work their way through difficult to erode rocks, sometimes even changing a river's course. Here along the Castor River, the water is clearly following a roughly east-west joint set in the upstream portion of the shut-in, but soon makes a sharp turn to follow a roughly north-south joint set instead, despite both sets being present throughout. Johnson's shut-ins provides another example of joint sets influencing shut-in formation. Here, erosion along crosshatched joint sets not only influences the river's course, it also results in some mighty fine swimming holes. So, to summarize, Ozark shut-ins occur where the modern landscape interacts with an ancient one, producing topographically unpredictable exposures of erosion-resistant igneous rock that alter river patterns for short distances. So if you get a chance to visit an Ozark shut-in, be sure to enjoy the modern scenery, but also try to envision the far more ancient landscape and its role in shaping the modern one. If you have further questions about Ozark geology that you'd like to see us address in this short format, leave them in the comments below. And if you found this content worthwhile, we'd appreciate any form of support you can provide for this independent channel, including sharing it with others, or leaving a tip via Ko-fi, or hitting the thanks button below.